Okay, so previously we talked about alcohol functional groups and where they're located on the infrared spectrum. And now it's time to move on, and it's time to go to our next functional group. And the next one that we want to talk about is basically a whole family. And the family of compounds are called the carbonyls. So the carbonyl functional groups will represent multiple different ones because there are so many carbonyl functional groups that are out there. So we're going to take a look at the family at one time. But before we start taking a look at the family, we're going to break down to kind of figure out what a carbonyl is first, and then we'll continue on with the infrared lecture series. So, if you've not seen this type of functional group before in a previous course or in a course that you're currently taking, what is a carbonyl functional group? All right, well, a carbonyl, as you would expect, has a carbon because it's called carbonyl, and that carbon has a double bond to an oxygen. And that is what we call the carbonyl functional group. All right. Now, out of this group, this C double bond O, there are multiple different ways that that can show up in a molecule. All right. So what I'm going to do is I'm going to put something over here and something over here, and I'm just going to put question marks here. And the reason I'm putting question marks there is because that's what will determine what type of carbonyl we have that we're trying to analyze or that we're trying to pick apart in the infrared spectrum. So carbonyl focuses on the C double bond O. And then out of the carbonyl umbrella, we will have multiple different functional groups that we can talk about that has a carbonyl functional group in it along with other things, and it makes it slightly different. So what does this basically look like in an infrared? Well, I do this second because it seems like out of all of the functional groups, this is the next easiest one for people to pick up. And again, just like before in the previous video, the y-axis is percent transmittance. So up here we have 100% of the light going through, and down here we have 0% of the light going through. And the x-axis, just as before, is wave number from 4,000 to 600. This wave number is per centimeters that we call wave number. And in the infrared spectrum, what I will see if the compound has a carbonyl is a big dip that looks like this. That is the presence of a carbonyl functional group. Now, the carbonyl functional group, remember we had words that explained the shape of the peak or the shift. This peak is going to be titled strong. It's a very strong band. All right? That means that it's a very deep peak that almost goes down to 0% and back up. We use the same word to describe an alcohol peak. Now, the alcohol peak said that it was broad. Well, that means very wide. This one is not broad. This one is not traditionally a very wide peak that happens on the infrared. But they don't call it narrow either. And the reason is because it can fluctuate back and forth. Sometimes these are pretty fat peaks, and other times they're very narrow peaks. But we're not going to give it a label as broad or narrow because we do see it alternate quite a bit depending on the type of carbonyl that it is. But we can at least call it strong because in every single case, traditionally this peak is a very deep peak. It goes all the way to the bottom and then all the way back up. Now, where does this number happen? Because we said the numbers are pretty important, right? All right, so this traditionally doesn't have a lot of wiggle room compared to all of the other shifts that are there. I mean, look at the alcohol group that we just talked about. It went from 32 to 36, right? That's a 400 wave number wiggle room that can be there. Well, for carbonyls, this number typically happens, we're going to say 1700. Now, that's typically the number I tell you every single time to look for. At 1700, this is the carbonyl peak. Or do you see a shift that happens at 1700? That's what I'm referring to with carbonyls. But keep in mind that there is a window here, and that window is a little bit wider than just that one 1700 number. It goes from 1650 all the way up to 1780. So if you kind of take the average between the two, you get something close to 1700, and because of that, I just rounded off to 1700, and that's our carbonyl peak. But bottom line, there's not a lot of wiggle room and there's not a lot of movement that's there. Okay? So with the carbonyl functional group, what you would traditionally see in an infrared is something that looks like this, right? First off, I don't see an OH group, right? That's something now I now know. I know what an OH group looks like on an infrared. So here the OH group comes down and it comes back up, but I don't really see that signal there. So there's no OH group on this molecule. The next one we're going to talk about is carbonyl. And we now know that carbonyls happen at 1700. Well, here's 1500, there's 1600, there's 1700, right there at that tick mark. All right, well, this is slightly over to the left, and that's okay because we know there's wiggle that's going to be involved. And I see a very strong peak that comes down and it comes right back up. And this is not broad, but maybe it's not narrow either. So this is a very hard peak to describe as far as width goes. But we can at least say they're very strong. So that's the presence of a carbonyl functional group. Now, that's just one piece of at least two pieces that we're going to eventually talk about in upcoming videos because, yeah, carbonyl is a functional group, but under the carbonyl umbrella, there's plenty of different functional groups that fall into that category. So there's other things that are there that's involved. And if I take a look at this infrared, this is the infrared of what we call acid aldehyde. And here's the structure down below, and there's my C double bond O. So I know that that carbonyl functional group is there, and the positive signal of that carbonyl functional group is this big strong peak at around 1700 that happens right here. Okay, so upcoming videos will take our first stab at a real carbonyl family, and then we'll work through them slowly but surely. Okay?